I would like to invite our next panel. The next panel is going to be about IoMT, or medical devices, and AI as it pertains to the subject. I know it's a great topic of interest for Itzik Ochav, who's sitting here in front, and many others. Lots of questions. The moderator is Dr. Fitzgerald, so I introduced you before.
Thank you very much, and we will accelerate and be efficient. So, Ilan and Russell, Jacob, and Yariv. So I'm going to jump right in. Ilan, I'm going to target you first, because you got up and you said you love to disagree and agree all in the same sentence, which I appreciate, because that's Irish as well as your background. You also said something that intrigued me, and you said that the machine learning and AI that you see in other enterprises are not necessarily applicable, at least from a security perspective, to healthcare. What did you mean by that?
I meant that right now, all the startups, it's not in the medical, are using machine learning and especially unsupervised machine learning, to tackle all sorts of problems where hackers are actually just using just basic machine learning to the AI to automate attacks, which means they are really scalable and they can do it, they test it in the field. They don't have to wait for that. They don't have to wait for, they have startup money from the mafia or governments, bad governments. But what I'm saying is they just go ahead and do it. They don't wait for it. And what it means that they will be better a lot faster than the tools which are general machine learning and AI tools are there to prevent anything like that from happening. And we can actually see it in the last year and a half. We already saw some automation tools and machine learning tools working within several coordinated attacks.
So you think the difference is whether it's supervised or unsupervised?
If supervised, unsupervised, and the question of how, it's a go-to-market strategy. The hackers just go to market.
But in healthcare, you have a wonderful quality, and that is curated training sets over time that you can learn from.
Right.
Sometimes you don't have that congruency in other enterprises. So it is somewhat of a convenient, if you will, environment to do supervised learning.
It is. First off, there's lots of data to train. And when you're training, you're still making money, which is also good.
Good point. That's a good point. Russell and Jacob, you both come with different views from Intel, for sure, as well as Russell, you've worked with a lot of the medical device companies, advising them about how to provide security. I'd love to hear your viewpoints, both of your viewpoints, coming from those industries.
Thank you very much. I think that the first thing is when we talk about medical devices, and I will touch AI also because it's very close to the things, is normally the hardware need to have a root of trust. Because without trusting the hardware, all the telemetry which this device should create and send can be a fake. And if you take a medical decision based on this untrustable data, this can lead to severe outcomes. So the first thing, how you can really trust the hardware? Where it's coming from? When you do implants, do you really understand who developed the hardware, the firmware, the software, how the communication between this device to the aggregator is happening, and later on what is happening with this data? And additionally today, we have also regulation which is coming into this direction also, which is the GDPR. All the privacy issue. We are talking about data in the medical sector. The privacy of this data becoming critical to the patients, but on the other hand, you want to use this data for analytics, how you do this. And if there is a research in one hospital, how you can share this with another hospital for the beneficial of the entire humans. So the basic idea behind that is artificial intelligence and big data analytics are important, but really think carefully before adding these new brand sexy names if you really need them. This artificial intelligence, without knowing exactly what you're adding, it's a totally new entry to your system. Clear point. Be very, very careful about that.
Good point, because DOS is the most secure, right? Russell?
So I agree with what Jacob said. Also, in working with a lot of the global manufacturers as well as hospitals, it's really a bifurcated problem we're talking about. 10 years ago, 10 plus, no one was really focusing on product security, right? Some of the things you're talking about just didn't exist I think it's a whole new discipline, right? As opposed to traditional IT security. So today, if you look at the problems we've heard about very well today, about the vulnerabilities in these cyber physical systems, many of them are medical devices, the time it takes to actually design a new infusion pump and then go through the whole approval process in the US to the FDA and so on, that whole life cycle, by the time you get that infusion pump in your hospital, it may have been designed 7 years ago. So bifurcated problem. Manufacturers, I think some of the largest ones are increasing their capability to think about security by design, privacy by design, and the new medical devices. Most of my clients that are healthcare providers don't care about that. They care about what we call the legacy device problem. I have devices today that aren't end of life, that are vulnerable. There is no real, solution, no patch. So what can you do for me today to mitigate that risk? And I think some of the solutions you've heard about, whether it's CyberMDX or those type of solutions, I think are the next best step. If you can't secure something, let's have a much better detective, predictive kind of monitoring capability. Understand the characteristics of what an infusion pump or an MRI ventilator should look like on the network, what it should be talking to, processing, and memory consumption, those type of things, so that when there is some malware that gets into the environment, we already have a better incident response capability tied into that, very super robust, monitoring capability. And I think that's where, machine learning can actually come into play to kind of make that an even more robust environment.
And who, in your opinion, you two are responsible for that? And we saw the example of Muddy Waters and St. Jude. You have St. Jude that produces the pacemakers. They produce them today. They've got their firmware. They've got their operating system set and approved. Now it goes into the hospital. I put them in, and then it goes to the home. And there is a problem with it from a security perspective. Am I responsible? Is the hospital responsible? Or is St. Jude responsible?
I can take that first. So what the FDA would say, what the FDA would say is it's a shared responsibility.
That's a cop-out, like the FDA, right?
Well, I don't know if it's a cop-out or not. Based on what I've seen working with my clients, because I think one of the most beneficial exercises I led a couple of years ago, I got into a closed-door session. Some engineers from a medical device manufacturer with the head of clinical engineering of a large health system, and let them actually talk about, from a clinical engineering perspective, here's what's important to me. Here are the kind of capabilities I'd like to see next generation of your device. Oh, that's interesting. And from an engineering perspective, I've never heard that because we got so many layers of legal on both sides and other, people in between. Those engineers are not really hearing directly from a clinical perspective what's important. So when I think of shared responsibility, that's where I'm thinking it's going, both for the legacy device issue. Hey, help me solve these current issues with devices that I'm going to use for another 5 to 10 years, as well as you're developing new devices, here's direct input on what we need from a security perspective.
Before we let Yariv and Jacob enter, let's just make sure we understand the specifics. There's 350,000 of these implants that are put in per year. There's between 2.8 and 3.2 million that are already implanted that are legacies. And the United States has 72% of all the lawyers in the world. So The FDA may cop out, but if I'm a lawyer and somebody's had a problem with their implanted pacemakers, I'm not going to go after me because I don't have any money. They're not going to go after the hospitals. They don't have any money, but St. Jude does. So I think the cop-out on that side of it makes sense, but from the other side, it's going to the companies. Jacob?
So this is very interesting because I was on another panel and they asked very similar question. An autonomous driving car making a car accident. Who is responsible for that?
Trolley effect.
No, it's very similar. So this question here is the following. When a company delivers a piece of hardware or a software or a combination, a product, it needs to comply to the specification of the customer requirements. The moment it complies to those requirements and there is an acceptance agreement between the supplier and the customer, from that point of view, the liability stop. Point. Only if there is a malfunction in the device, the acceptance company should test and evaluate this device. The same in any business, no doubt. And any company will not be take any responsibility more than the cost, the total cost of the total devices. It doesn't make sense. Because imagine yourself, Microsoft, okay, I'm not doing promotion to anybody, but if Microsoft will take liability about all the systems that they are installed, it is impossible. So this is the basic rule that is happening here. So the reason that the integrators, which take the responsibility, taking these different components, make a product, and later on being put in bodies or any other medical equipment, need to be really, really focusing on the cybersecurity aspects. And not for now. What will happen in about 5 years or 8 years? The life cycle of this product. This is the dangerous here. Because when you, maybe today is already been secured and penetration has been done, and Ilan can tell you about different things that he did with hacking those activities or testing them. I may say, we don't say hacking here, testing them. But today it may be secured. But maybe in 1 year there will be a new tool which can hack it. Ilan.
So, Yariv, you come from a different angle here. You come from the world's
company.
Yeah, real cybersecurity company. We're just talking fluff here. So you provide real substance for other enterprises. How do you look at this healthcare arena, and is it of interest to you? And do you think there's congruencies in what you've taught the world to what we can apply here?
So it's of great interest for us, and we take a more of a holistic approach toward IoT in general and Internet of Medical Things in particular. Because eventually, when you look at a hospital, yes, it has all those Internet of Medical Things, and I relate to that, but you're in an environment which has other Internet of Things, and you're within a building. So in our view, you need to protect all of that environment because it basically increases the attack surface all around. Not just because Internet of Medical Things are more prone to cyber attacks because they have the old operating systems, because everything you talked about, the regulation and things of such. But because you have all those other things which are out there that can attack the same system. And now, in the past year, I've met around few dozens of hospitals worldwide and met with CISOs and CIOs. And some of the feedback I got, I'm worried about Internet of Medical Things, but what if somebody hacks into my elevator and I won't be able to take people from the ER to the operation room? They'll die, right? So this is there are a few aspects to cybersecurity when you look into a hospital. But to be more specific about Internet of Medical Things and artificial intelligence, so we see 3 main pillars of approaching the problem. One is, and it's to a certain extent similar to what MedDX mentioned. So it's one is visibility into the network. You want to understand what is connected to the network, but across the network, not just the medical things, but the cameras and the TVs and the printers and the coffee machines potentially. Then you need to provide segmentation, but this needs to be very automatic because when you talk to IT people, not just in the healthcare industry, but also in other industries, they want automation. If they'll need to decide each and every device where it goes to which in every segment, It's too much work for them. This needs to be like an automated policy for them to make sure they can segment devices. When you segment, then you already solve a major part of the problem. And you'll be surprised again that when I came to hospitals, many of the hospitals had flat networks. I was astonished. Like everything, the computers, the security cameras, everything is on the same network. So that's already solving a major part of the problem. At the end, relate to threat prevention, which is partially based on AI. Because you want to really do some anomaly detection. You want to understand what's the communication channel, the protocols, are they communicating? Is it something which is not supposed to happen? Maybe there's more communication or the message is not as it seems. Those are the things we're dealing with, and healthcare is definitely one of our first things we're looking at when solving problems in the IoT space.
So people are looking at segmentation for sure, because it's, in other industries, a very popular way to do it. Do you think you can go into these behemoth hospitals, and we could ask some of the CEOs of hospitals, and actually get them to segment? Is that a relatively easy thing to do?
You need to have some building blocks as part of that system, obviously. You need to have some security gateways. You may need to have some NAC solutions as part of the hospital. But if you take those building blocks and you combine them, you'll be able to apply various policies that will help them segment the network.
And it's not that complicated, right? Those policies are rule-based.
Yes.
Right? And segmentation and rule-based is something simple, but it's just like, trying to get the people, the employees that are the factors here, just educated. So we got education, we have segmentation, and we have basically rules that could make a big difference just by that.
Yeah, that will be definitely a good start.
Okay, good. Ilan, you've been thinking about this in a lot of different ways. What do you think about this whole thing about healthcare? I'll kind of give you the final word here, because we're kind of very vulnerable, very open, and not very educated with respect to security, which is, the triple threat itself.
I think we've been focusing on threats to the health sector specifically, and I think the next big thing is going to come, because WannaCry wasn't intended for healthcare. It's just internet scan, infect whatever you think. Those tools are getting a hell of a lot better. So it's not even about, I'm worried about medical devices and stuff because that's what I do for fun and non-profit. But we're going to see like a huge amount of non-specific attack on healthcare, which were trained on anything else. And they're just going to hit the healthcare hardest because the IT security level is lowest. So any type of security, it doesn't even have to be specifically for devices or whatever. Any segmentation, any NAC, any policies, awareness campaigns for doctors. I've been doing a lot of talks for doctors. Anything will help. It's still going to hit us.
You predicted, as you said in your talk, that this is going to be a big issue in the next 3, 4, 5 years.
I don't know. I'm not. You hear it from security companies all the time. The next attack is coming, whatever. And even the antivirus company says, yeah, we sell antivirus, but it doesn't work.
Yeah.
So I'm not trying to sell anything.
Well, but most of those enterprises out there have multiple solutions. It's managing all those solutions that gets to be the challenge. Exactly. In healthcare, we don't have that problem. We have insurance, a little bit of firewalls and antiviruses, and that's it.
I think the main problem is IoT is coming. I'm not worried about specific. We're doing systems of systems, which means that the insulin pumps uses the same ARM architecture than anything else. And we're using the same. And unfortunately, we're using Windows for everything. I think, by the way, I disagree with you. Microsoft should pay everybody's ransomware ever.
Yeah.
It's a business for them. They want you to buy a new operating system every year. But I think what's happening is that we're going to be subject to attacks on common denominator systems without any, not healthcare, driven by AI, machine learning, and a huge amount of scale that the bad guys are developing right now.
Listen, we're under a little bit of a time constraint. These gentlemen up here are very knowledgeable, so please meet with them afterwards. But, as a healthcare provider, I'm very excited that we're starting to get more awareness here, because this is important for not just the healthcare system, but for patients. And this is an important issue, and I certainly thank everybody for being able to participate in this. Cyber, maybe at healthcare it should be called cyber safety, because safety is more of an embellished word, at least in medicine, than security. So thank you very much.
Thanks. Thank you very much, Peter. Thanks for distinguished speakers, panelists. Thank you very much. Well, as an optimist, I refuse to take any negative spin on today's recent discussions, and just say that I think that this whole day has been an enlightening point of start in investing in a safer cyber healthcare environment. We're nearing the end of the day. Thank you very much for staying up to this very late point in today's event.